Hello ladies and gentlemen, today I'm going to be going over three different things. I'm going to be going over Pythagorean Theorem, Circumcenter, and Incenter. So we're going to start with Pythagorean Theorem. So Pythagorean Theorem you should be familiar with from middle school. So Pythagorean Theorem has to do with right triangles. So the first thing we need to do is talk about parts of a triangle. So the parts of a triangle, the two sides here, sides A and B, are called the legs. Side C is called the hypotenuse. And we call them A, B, and C so we can use them in the Pythagorean theorem. So the Pythagorean theorem is used to find the missing side length on a right triangle. The formula for that is a squared plus b squared equals c squared. So I'm going to go ahead and move on to example 1. I'm not going to do all of these examples. I am going to leave some to you. So in this problem, I have A is 7, B is 8, and C is x. So I'm going to plug those in for my formula right here and solve it to find the missing side length of the hypotenuse. So I get 7 to the second power plus 8 to the second power is equal to c squared, or x squared in this case. So 7 to the second power is 49, 8 to the second power is 64, is equal to x to the second power. 49 plus 64 is 113, is equal to x squared. And to solve for x, we're going to take the square root of both sides, which gives me x equals the square root of 113. And the square root of 113 is approximately 10.6. So my missing side length here is approximately 10.6. So that's how you use Pythagorean theorem. I'm going to leave the rest of this page to you because it should be a review. If it's not, make sure you ask questions in class and we will go over it. So next thing we're going to talk about is circumcenter. So the circumcenter is this point P right here. So the perpendicular bisectors are what make up the circumcenter. So the perpendicular bisectors are these three lines here. They make up the point here that's called my circumcenter. The circumcenter is always equidistant from the vertices of the triangle. So they're always equidistant from these 3 points. That's where these other 3 lines come from. They are all equidistant. So they want us to list the perpendicular bisectors. I'm not going to do this part. This part is listed out on yours. But what I do want to talk about is the congruent segment. So because we have a perpendicular bisector, that means that this segment is congruent to this segment. That this segment is congruent to this segment, and this segment is congruent to this segment. And we also know that because this point P is the circumcenter, I know that all of the distances from my circumcenter to the vertices of the triangle are all congruent as well. So that's one thing that's really important about the circumcenter, is that you know what lengths are congruent and which ones are not. So let's look at number 1. So it says Z is the circumcenter of triangle TUV. So Z is this point here, and it's the circumcenter of triangle TUV. So we are going to find the missing side lengths over here for this triangle. So first thing I want is TU. So TU is this entire length here. So this piece right here is congruent to this piece. So if this is 19, this also has to be 19. And 19 plus 19 is 38. So that's TU. VY is this segment here. Well, I know the whole length here is 34, and I know that it's cut into two even pieces because I have a circumcenter here. So that makes this length here 17. So that makes that 17. Next one is UZ. UZ is equidistant with all of the other vertices here, with all these other 3 lines. I already have that measurement of 21. Next one is WV. WV is right here. To find WV, I am going to have to use my 2 values that I have here and here. So 15 is A and 21 is C. So I'm going to set up my Pythagorean theorem. So I'm going to have, I'm going to flip this up so that way it's the same as what's on your note. So I have x to the second power plus 15 to the second power equals 21 to the second power. A and B can be flipped with each other. You don't have to just keep A with A and B with B. A and B can be interchanged. So if you want to set up your formula a little differently, you can. So I'm going to simplify this. I get x squared plus 225 is equal to 441. I'm going to subtract 225 from both sides, and I get x to the second power equals 216. And when I take the square root of that, let me double check my notes here. So the square root of 216 is 14.7 roughly. So that looks like a typo in the work part, but it's correct on the side of your notes. I hope everybody sees that. I accidentally wrote that down wrong and forgot the decimal pointer. It got left off of the copy. So last thing I need to find is TV. TV is this whole length here. So I already found WV is 14.7. That means that this piece is also 14.7, which makes the whole thing TV 29.4. So next problem, they tell us H is the circumcenter of triangle BCD. So this is my circumcenter, and I'm trying to find all these missing measurements over here. So I'm going to start with GD. GD is 12 because the whole thing is 24. So this is 12. BC is this whole thing, which one half of it is 7, which makes the other half 7, which makes the whole thing 14. EH is this piece here. Now, I don't have a measurement for that one, but I can use Pythagorean theorem because this makes a right angle there. And because it makes a right angle, I have A, I'm missing B, and this would be C. So for part C, I do 7 to the second power plus x to the second power equals 13 to the second power. 7 to the second power is 49 plus x to the second power is equal to 169. We subtract 49 from both sides. X to the second power is equal to 120. And when I take the square root of both sides, I get x equals approximately 11. It rounds to 11. So EH is approximately 11. Then for part D, I need to find FD. FD is over here. So I know this length here is 13 because it's 13 over here. And remember, the circumcenter is equidistant from my vertices. So I'm going to set up Pythagorean theorem again. 3 is going to be A. I'm missing B. 13 is going to be C. So for part D, I'm going to set up 3 to the second power plus x squared equals 13 to the second power. So I get 9 plus x squared equals 169. I subtract 9 from both sides, and x squared is equal to 160. I take the square root, and I get x is equal to 12.6. So FD is equal to 12.6. And last one is CD. So I need this whole length here. Well, I just found the FD is 12.6. So now that I know that that's 12.6, I know that this is 12.6. And 12.6 times 2 is 25.2. So last example on this page, it says M is the circumcenter of triangle GHI. So first measurement they want is GI. GI is this whole side here. Well, I already have half of it is 30, so this other half is 30, which makes this 60. Next one they want is MH. So MH is this right here. And let's see, they do not give me the measurement for any of my lines going to my vertices. But I do know that this is 31 because this is 31. So I can set up my Pythagorean theorem. So I can do a squared plus b squared equals c squared. So for part B, I'm going to set up 31 squared plus 14 squared equals x squared. 31 squared plus 14 squared is 1,157, and that's equal to x squared. I take the square root of both sides, and I get x equals 34. So MH is 34. Sorry about that interruption. So next one we're finding is IK. So IK is this length here. So IK I'm going to have to use Pythagorean theorem for again. So this length here between my circumcenter and I is 34. I just found that. So 34 is C. I'm going to make 23A and I'm missing B. So for part C, we're going to set up 23 to the second power plus x to the second power equals 34 to the second power. And when I simplify that, I get 529 plus x to the second power equals 1,156. I subtract 529 from both sides. And when I do, I get x squared equals 627. Then I take the square root of both sides and I get x equals 25, roughly. So IK is 25. Next one I want to find is HI. HI is this whole side here. So if this was 25, then that means this is 25, which makes that whole entire side 50. And MG. MG is this segment here, and that would be 34 because it's from my circumcenter out to my vertice. Next thing we're going to talk about is the incenter. So the incenter is made up of the angle bisectors. So the angle bisectors make up the incenter. So this point P is my incenter, and it's made up of these lines here, my angle bisectors. The incenter is always equidistant from the sides of the triangle. So these three segments here are all congruent. So these three segments here are all congruent. So again, I'm not going to list all of this out, but please make sure that you know what all is congruent as far as congruent segments go, because that's really important to know and understand. So next problem, P is the incenter of triangle JKL. So they want us to find NP. NP is right here. NP and these other two sides are equidistant from the incenter. So this one is 8. NK is this piece here. For that one, we are going to use sorry about that brief pause. So because we have an angle bisector here, so this is an angle bisector, which means it cuts this angle in two different pieces and they're congruent to each other. Because of that, that means that these sides are congruent to each other. So this is 17 because of the angle bisector. So I don't even need any of the rest of this picture. So this is just like from our angle bisector problems that we did on the last video. If you just have this picture, that's all you need for that. So this is 17. Give me just a moment. Let me erase that big giant blob of mess I just drew. Okay. So next thing we need is PK. So PK is from here to here. On this one, we're going to have to use Pythagorean theorem. So A is going to be 8, B is going to be 17, and C is going to be PK. So this is for part C. So I have 8 to the second power plus 17 to the second power equals x to the second power. 8 to the second power is 64 plus 17 to the second power. When you add those up, you get 353 is equal to x squared. So to solve that, we're going to take the square root of both sides, and we get 18.8 is equal to x. So PK is equal to 18.8. So for part D, we need to find LO. So to find LO, I'm going to use Pythagorean theorem again. This side here is 8. So what I can do is set up 8 to the second power plus x to the second power equals 13 to the second power. 8 to the second power, 64, plus x squared equals 13 to the second power is 169. I'm going to subtract 64 from both sides, and I get x to the second power is equal to 105. Then I take the square root of both sides, and I get x equals 10.2. Next problem we're going to work on is number 5. It says G is the incenter of triangle ABC. So we're trying to find these measurements again. So first one I want is GD. GD is from the incenter to D down here. And that one is, I do not know that one, so I have to do Pythagorean theorem for that. So for part A, I'm going to have A, B, and C. So my right angle here points to the side that is C. The other two, the order does not matter. So we get x squared plus 35 squared equals 37 squared. So when I simplify this, I get x squared plus 1,225 equals 1,369. I subtract 1,225 from both sides, and I get x squared equals 144. And when I take the square root of that, I get x equals 12. So GD is equal to 12. And I'm going to write that in my drawing. So this is 12. Next one they want is BG. So BG is from here to here. So I have, this is 12 because remember all three of these are equidistant. So that is 12. Let me get rid of that mark because that makes it look like it's 121 and it's not. So I'm looking for BG, and this measurement here is 12 because I found that one is 12, and this one is also 12 from here to here. But I have these two pieces here, and I need to find my hypotenuse right there. So for part B, I'm going to set up Pythagorean theorem with 6 squared plus 12 squared equals x squared. So I get 36 plus 144 is equal to x squared. 36 plus 144 is 180, and that's equal to x squared. We take the square root of both sides, and we get x is equal to 13.4. So this is equal to 13.4. Next measurement I need is FC. So FC and CD are congruent to each other, so that's 35. And last one I need is BF, is this measurement here. This side and this side are congruent to each other, so that makes that 6. And last problem we have, it says if S is the incenter of triangle PQR, and they give us a bunch of measurements. So first thing I want to do is look at my picture. This picture is a lot different looking than the other ones I've dealt with. So these are truly the lines that make up the incenter. The three angle bisectors make up the incenter of the triangle. So if S is the incenter and the measure of angle PRQ, so PRQ is this whole angle here, is 8x minus 10. They tell us that RQP, that's this whole angle here, is equal to 14x minus 4. And that angle PQR is equal to 7x minus 5. Did I do that right? RPQ. I did that wrong. My mistake. So this was supposed to be for angle RPQ. So RPQ is this angle here. And that one is 4x minus 14. And then this last angle here is 7x minus 5. So now that I've got all my information from my sentence up above drawn on my picture, I'm going to start working on finding the different measurements now that I have that. So first thing they want is the measure of angle PRQ. So PRQ. In order to find the measure of PRQ, I have to have x because PRQ has x in it. So I have to find x in order to find the measure of PRQ. So the three angles inside of a triangle are equal to 180 degrees. So I have 4x minus 14 plus 7x minus 5 plus 8x minus 10 is equal to 180. So I'm going to combine my like terms. So 4x plus 7x plus 8x is 19x. And then when I add all my other like terms, I get minus 29 is equal to 180. I add 29 to both sides. and I get 19x is equal to 209. Then I divide by 19 on both sides, and I get x is equal to 11. So x is 11, that's not the measure of the angle, that is what x is. So what I'm going to do is take and plug x in for this. So when I do that, I do 8 times 11 minus 10, and I get 78 degrees. Next thing they want is RPQ. So RPQ, I plug x in for that one. So I do 4 times 11 minus 14, and I get 30 degrees. Next one is PQR. So again, I plug 11 in for x here. So I do 7 times 11 minus 5, which is 72. Next one is the measure of angle RPS. RPS is this tiny angle here. So this tiny angle here. So remember, the incenter is made up of the angle bisectors. So all I have to do is take the measure of RPQ and divide that in half. So if RPQ is 30, that's going to make RPS 15. Next one is PQS. PQS, again, is this small angle here. And if I know that PRQ is 78, then when I divide that by 2, I get 36. Next one is PRS. So PRS is this small angle here. And again, if I know the big angle, and this is half of it, I know the small angle. So the angle that I'm looking at is PRQ. I'm sorry, I mixed up the last one. It was supposed to be PQR on the last one. This one is PRQ. And half of PRQ is 39. Then PSR, PSR, PSR. So to find that one, what I have to do is take this angle, take this angle here, angle P over here in the small triangle, angle R here in this small triangle, add them up and subtract it from 180, and I get 126. So thank you so much for watching this video. If you have any questions, please contact me, and have a great day. Bye-bye.